We will be recording this today, and if you want to go back and listen to it again or share with a colleague, that will be available after the webinar today. All right, we're going to kick things off. Thank you for joining us. Glad to see you here. This is 5 myths about encryption on IBM brought to you by Fortra, which is the new face of help systems. We're your cybersecurity ally with exceptional protection and peace of mind along every step of the way in your security journey. My name is Sandi Moore. I'll be your host today. And I have been working in security for many years. I've actually started about 20 years ago working on IBM and was quickly introduced to security. I've worked in many different capacities, and I'm glad to be your host today from Fortra. All right, so I'm sure you're all familiar with the show Mythbusters. It's on Discovery Channel. It's something that I enjoy. I would love to be able to blow things up and prove things wrong. But today, I think we're just going to keep it a little bit less explosive and maybe just talk about some basis of truth, or whether or not some of these myths are surrounding encryption on IBM can just be debunked, or if maybe they land somewhere in between. We'll just jump right on in. Myth number 1, disk encryption is the silver bullet. So when we're talking about encryption, knee-jerk reaction that I hear a lot is that we're going to go ahead and just do full disk encryption. And starting at v6.r1, IBM actually gave us the ability to enact encryption across the entire disk drive, meaning everything that's placed on the disk is first encrypted by the disk controller, and then written out in that encrypted form seamlessly across the entire disk unit. So benefits to that. And my gut feeling answer is that this is what we might need to do. So its benefits here are that it's very fast. It's going to be pretty seamless. Most IBMIs have those crypto processors or the coprocessors built in, or have the controller cards that are going to be able to handle that encryption at the hardware level. It is the fastest way to do encryption and decryption functions. The question here, though, is if there's going to be any impact when it's implemented. And at the hardware level, this is actually going to be some minimal impact. Systems are ready to go. Seems to be fairly non-invasive. And that's definitely a benefit when we're talking about encryption in our databases that hold our valuable data. Of course, we have to talk about what is invasive is that any changes that we make to the application or database structure in order to accommodate that encrypted form. And that would, of course, be considered invasive, and most of you don't want to do that. I get it. So that application or database has no interaction or visibility to the encryption happening when it's done at the disk controller. So that's where the non-invasive comes in. So is that a silver bullet? It's plausible, all right? I'm gonna not say it's not gonna help at this point. However, there's definitely some additional considerations that we need to think about. It is gonna be seamless, and it's quickly implemented, which is definitely significant when we're talking about project undertaking, such as encryption. And so it's gonna be very appealing. Before we actually start jumping up and down, excited that, yay, we've solved the problem, we should definitely dig a little bit deeper. Windows laptops, for example, we're going to go over to Windows. You have multiple disk drives attached to it. And if we use that as an example and look at it in the simplest form, you can actually take out taking out any RAID structures or other protections. You have basically multiple drives on that server. So makes that easy, right? And then when you take the case off, you can remove one of the drives and put in a secondary server, and it's probably going to work well, and it's going to be able to read the contents of the drive, right? So if we've encrypted all of that and you take that drive, plug it in somewhere else, the data's still encrypted, and so that encryption, that full disk encryption, is actually helpful. So if there is the possibility of that disk drive being stolen or reallocated, or disposing of it improperly, that data may be exposed. So that's where the disk encryption is going to be helpful. So how does that apply to IBMI? Well, unfortunately, it doesn't really, because IBMI doesn't store data like Windows does. And so basically IBMI has taken the approach of scattering disk data across all of the drives in an array. And so not unlike a Jackson Pollock painting where it's just scattered, it's really takes that parity protection. IBMI is balancing it across all of the units. And so you can't simply remove and install into another system. So, and really, if most companies that we talk to, they're really good at the physical security. So what is the possibility of somebody actually stealing that disk anyways? So it's really not going to be a benefit in the approach of plug and play. Disks aren't going to be able to be movable. It's not really helping us. Now, what it does do is that having that encrypted internal disk in the server does give us some limited benefit. It is faster, it's non-invasive, and if you are doing that, you're going to have some limited benefits. So you're going to have a compliance check mark. You're going to be able to tell that auditor that, yes, in fact, I am doing encryption. And without digging any deeper, it looks great on the surface. You've got that line item taken care of. Now, I can say that if you are backing up to an external disk, that physical drive unit in a different location, you are actually getting some benefit there because it is sending in an encrypted pipe. So there is some protection that way. While it's indirect to our conversation today and ensuring that we're protecting the data at rest, it does have some advantages to it, and the functionality is there. So you can certainly take advantage of it and use it without any concern. Think of it like you've got a firewall around your environment, and that's great, but you always have to add some additional layers. So this is really where it's nice to have, it's good, it's a layer, but it's not really solving the problem. One of the big inhibitor to full disk encryption is that it doesn't solve, well, it does solve the requirement to add encryption layer, is that the problem is that the encryption decryption is not going to interact with your applications or with the operating system. And basically the system makes no differentiation between authorized functions or unauthorized functions. So basically if a user has the ability to sign on to the system, it's going to automatically decrypt the data, and whether that access is authorized or not. And so that clear text is available as soon as authorized users sign on to the system. And most IBMIs I know, you have to have credentials to get on the system. So as soon as you've got those credentials, whether you're who you say you are or you're a threat actor who has taken your user's credentials and signed on to the system, they get that data in the clear text. So from a security standpoint, this really is not necessarily going to make or break the encryption process. So this is not solving the problem of protecting the data from the users who are going to expose it. So as far as I'm concerned, I think that with full disk encryption, this myth is definitely busted. This is not really going to solve the problem of protecting data at rest. While it does have its valid points, it does have some benefits to it. It is really not going to be providing that data protection that is going to actually provide the security that you're looking for. Myth number two is the approach to encrypt everything, that this is what you should be doing. So is this really a good idea? Let's talk about it. All right. So actually, I like to use as an example here is the Enigma machine. And if you're not familiar with it, it was a cipher machine that was developed and used in the early to mid 20th century and to protect communications for commercial, diplomatic, and military entities. And the Enigma machine itself had some cryptographic weaknesses and was used by the German government. It was actually some of their practices and procedures that actually allowed the Enigma machine to be decrypted and the encryption to be broken with it. So through a series of unfortunately highly repetitive characters, it actually emerged, a pattern emerged, and allies were actually able to figure out what was being said. So really the purpose here is to encourage you to be cautious of encrypting high volumes of data, because that highly repetitive data pattern is going to be able to emerge. And once that you've figured out one piece, the entire system has the potential to be broken. Another thing you need to consider with trying to do full encryption of everything is performance. And so if you were trying to encrypt everything on IBM, there's definitely going to be a performance hit. When we're talking about disk encryption, that's really fast because it's done at the hardware level. But when you're taking and trying to encrypt at the software level, you're really going to have to consider how much you're doing, because every request to a field is going to trigger for every record in every field, or every field in every record. It's going to need to be decrypted. And so there could be some significant overhead that is going to be at play. And we certainly don't want to actually have the security of our data be swayed by the fact that the performance is not great. So definitely a consideration here. We do have conversations about encryption. Of course, you have to talk about what should actually be encrypted. And evaluating that data is essential. So there's really two parts to that. First is deciding what you consider to be sensitive and doing some inventory and just finding where the data is. So sometimes it's dictated by regulatory mandates, if you've got social security numbers, credit card numbers, but there may be other valuable data to the company, such as trade secrets, intellectual property, formulas, anything that you determine that would be sensitive to you, the business, you need to identify. Second, of course, is that where and how is that data stored? So there may be some data in multiple databases, and those databases may not be normalized. So you really need to actually prioritize it. So classify it by levels of sensitivity, and then focus on the data that is in fact found to be the most sensitive. It can be overwhelming to start looking at this, but it is tempting to lean towards that full disk encryption because of that. But really the focus should be on the sensitive data. All right, I think I'm gonna bust the encrypt everything. Between the fact that data patterns will start to develop, and the keys are not necessarily, the encryption is not going to be protected because the patterns have developed. You don't want to impact your environment either, and encrypting everything is really going to slow the system down. And really, you're better off figuring out what applications you have on the system and identifying where that data is and focusing on that. Myth number 3. So encryption algorithms are not created equal. So really this is the idea that whether or not you can just use anything you want and it is all going to work just fine. There's really many security commandments we talk about in our webinars, presentations, as well as conversations with customers directly. And that's to the necessity and the criticality of implementing good security controls. But if you break down the commandments, 2 of them, of the many, are actually directed at protecting the sensitive data. And if you look at the regulations, they specify sensitive data needs to be protected. And then secondly, they don't usually tell you how to do it, but they make a generic reference to strong encryption. And the definition of strong encryption changes over time, so it's intentionally vague when you start looking at those requirements. And really, the worth of any cipher is based on their computational security. If a cipher is computationally secure, means the probability of cracking that encryption key using current computational technology and algorithms within a reasonable amount of time is supposedly extremely small, but it's not impossible. So in theory, every cryptographic algorithm except for the Vernum cipher can be broken, giving enough ciphertext and time. You know, over time, the definition of strong cryptography has changed, but in general, it's left broad. But the PCI Security Standards Council does actually specifically call out the requirements, and it is unusual, but they in fact do mention that strong key lengths are required with a minimum of 112 bits, and then proper key management practices as well. And the ensuring that industry tested and accepted standards are used and algorithms for minimum encryption strength are defined as well, including AES, 128 bits and higher, TDS, RSA, ECC, and EIGMO. So really, the idea is that they have specifically called out the requirements. But regardless, it's not a set it and forget it situation. So because it does evolve over time, encryption methods that have been considered strong have been broken. So this is definitely something that you continue to have to address. When we look at symmetric versus asymmetric key systems, one of the first differences is the fact that there's these two basic systems. Symmetric keys, there's a key used for both the encryption and decryption function. So it's a single key cryptography. If I send you data, then I also have to send you the key so that you can actually read the data. So how do I send the key without exposing the data? So it's a bit of a catch-22. Then there's asymmetric cryptography comes in where there's actually two keys involved, where you've got a public key for encryption and then a private key to decrypt. You don't actually distribute the key. And you don't have to use one or the other of these key systems. You can actually use them both. And that symmetric key for data at rest, and then use the asymmetric key when you have to share the data with someone outside of your organization. And really, the decision about which type of key system you're going to use is dependent on what you're actually trying to accomplish and where you're trying to protect the data. Of course, the strength of the encryption method is going to be influenced by three different factors. First, there's your choice of algorithm. There's numerous algorithms, the AES, DES, RSA, triple DS, which are different types of algorithms and are going to apply whether you're using an asymmetric or a symmetric approach. The length of the key is important, so the longer is definitely better. The complexity and number of combinations available, as well as the length, is going to be more resistant to a brute force attack. Of course, the secrecy of the key. Pun here is that the key to the encryption is the key itself. Keeping it secret is definitely going to influence the resistance to abuse of that encrypted data. So you don't have the key, you can't abuse it. If you expose your key, you've exposed the data as well. I'm sure you've seen charts similar to this, infographics talking about how long it can take to brute force hack an encryption key. And on the right-hand side of the graphic, you can see how long it would take 7 billion people on the planet to break a 256-bit encryption key. If I had to I had to actually look this up, but that the number of years there is actually 77 septillion years in order to break it. The thing you need to remember here, though, is that even though the statistics are staggering and it seems like, wow, this is great, the reality is that it would actually break before somebody got through all of those combinations. So, you know, think about when you're looking at your PIN number. It would take 9,999 attempts to break it, but if your PIN number is 0003, it's going to break pretty quickly. And you don't have to go through all of the combinations in order to break it. You just have to hit the one that matches. So, you know, these infographics are really encouraged taking with a grain of salt, because even though longer is better, you're not going to go through every combination. Think about when you're searching for something. You say, oh, I found it in the last place I looked. Well, of course it's the last place you looked, because you stopped looking when you found it. They will stop trying to break the key when they break it. So once you hit that combination, it doesn't matter how many additional combinations there are once they've actually matched it. Not saying it's not important, but you definitely need to think about that. All right, so I think that it is confirmed encryption algorithms are not all created equal. There are some that are stronger than others, and you need to ensure that you're using industry standard encryption algorithms and utilize sufficiently strong keys, and making sure that you are using the standards that are available. AES is typically the standard here in North America. It is selected by NIST as well for the standard encryption protocol. Myth number 4, encryption is a get out of jail free card. I loved get out of jail free cards. These are nice. You can actually pass on by and not have to worry about it. But, you know, unlike the myth that if I encrypt everything, I'm off the hook, when we're talking about regulatory mandates, they are increasingly calling for encryption as a way to protect. And there's ways to obfuscate the sensitive data so it's compromised, it can't be used, or is unrecognizable. If we look at GDPR, which has been in effect for a few years now, they do speak clearly that encryption is required. And if there's a breach, encryption alleviates the reporting requirements, but it does not actually remove the requirement to report it to the overseeing authority. So you still have to tell them about it, but you don't have to tell the person whose data was exposed, because it was encrypted and protected. You need to keep in mind as well that if you're working with GDPR, if you're unable to access or recover the data, it is actually seen as a violation as well. So ensuring that you, in fact, meet those regulatory requirements, and consider that encrypting itself isn't always going to match up with everything. And if you're good example of this is a ransomware attack where encryption is involved, and a lot of times there is extortion with that as well, and the data is not going to be exposed, but it's damaged beyond repair, and that would unfortunately be deemed as a violation. So making sure that you're meeting those requirements is that you use that strong encryption method and guard the keys. They are going to be watching and checking to ensure that, in fact, you are meeting all of those layers of protection. So encryption is not an electronic get out of jail free card. Really, it's a valuable part of a good overall security infrastructure, but it can't be the only control in place. So ensuring that you have actually addressed the rest of it as well and have some good security practices is going to be critical in addition to that encryption layer. Myth number 5, encryption is complicated. So it certainly seems like it's me, based on the fact that, you know, IBM added some APIs that can actually allow for encryption. But with the way these APIs work, allowing for that encryption and decryption functions, it does rely on some changes to the system. And when you're doing that API programming, it relies on the database structure supporting the format of the data in its encrypted state. So that can actually require changes to your length and character set of the field, which is definitely invasive. The API calls also only when the data is accessed. So if the code had to be added to the applications for a change in the field, you also need to consider other factors, including the sorting, as well as the need to recompile your programs. So it's not a drop it in and run with it. Those API calls are only made when needed, so it helps with the speed of the data availability and certainly helps with efficiency of the encryption, but you also need to consider that alternate methods to download the data, there's no integration with the operating system. So you can decrypt the data if you're going outside of the application interface where that API has been added. So whether it's a legitimate access to the data or not, you're going to have to go through those extra steps to give users access to the readable data. It's a good solution for application providers because they can write it once and then deploy it many times over and over. But for most organizations and everybody else, the people who own the business or have their own applications that they've written in-house, it is very complex. So this is an example of, so you can get a real feel for how invasive these database changes can be in order to support encryption. So in this example, the data happens to be a social security number field. So the before encryption, it's a 9-numeric field, but when you add that encryption, it needs to support other characters, and it's now actually going to be a 16-character alpha field. And it's going to require recompiles to the application, and even if the database file isn't used much in that specific program. So definitely invasive there, modifying your database in order to implement. This example shows invasiveness of the application changes themselves. So you have to determine if the user's authorized, then you need to call the decryption routine. Otherwise, you're going to have to mask it. So not overly complex, but it's considered extremely invasive because there's a lot of work that you have to do with those applications. The database trigger was added as part of the database structure in V5R4, and it allows us to fire off an event when data is read, changed, or deleted. The idea here is that we can do something at the database level without having the application having to be involved. So not unlike the API approach, you still do have to make structural changes to the database for encryption, but there's no invasive changes to the application layer. And while it's true that the encryption side doesn't require changes to the application, in order to decrypt the data, you do have to make some application changes. And those read triggers can have some security restrictions on them from modifying the way the data looks. So these can definitely be impactful. Unfortunately, there is no OS integration with this. Even though the trigger support is provided by IBM, if you run a query outside of the application, then you're going to get that encrypted data. And of course, there's going to be some performance considerations with this as well. With that read trigger, every time it's called, it involves the program. If you do a select all, there's going to be a pretty significant impact. And on changes and deletes, it's not as big of a deal, but that read can certainly be impactful to the users. When IBM's Red Book was released, it was central to vendors due to the complexity because of those APIs, the triggers, and the SQL directives for encrypting data at rest. But good news is when IBM i 7.1 came along, they added field procedures. And unlike the APIs and triggers, with field procedures, no changes need to be made to the database structure. The field length is not impacted, which really makes it more accessible to the average user or organization. It's not invasive to most applications. The data appears the same to the application, and it doesn't need any special accommodations, which is nice. You're not having to overhaul that database. It's fully integrated with the operating system functions. So basically, regardless of how the user's requesting the data, the field procedures are called and the data is presented in the format designated for that specific user. It's decrypted if appropriate. In other words, if you're going outside of the application, you're going to see the view of that data that you're supposed to see because that field procedure program gets called. It does allow for programmatic control, so you can easily determine if the user should see the full data, partially masked data, or nothing at all. And of course, there are performance considerations with this, as the fields are being decrypted as requested, which can add some overhead. So really, with this, there's some careful planning to help balance the performance while still meeting the needs of protecting the sensitive data. And with any security project, it's all about finding the balance, protecting the data, but still making it available. So I'm going to say it's not too complicated when you consider the additional functionality that's been added. So in the theory, it is certainly highly complex. However, depending on how you go about it, implementation doesn't have to be complicated. So I'm going to say that one's busted. So we had 5 myths. Only one of those was actually confirmed. So some other things to think about when you're looking at encryption is the key management. So of course, you encrypt the data, but you also have to ensure that you consider how those keys are going to be protected. Make sure that they are available for the decryption as necessary, and that they're also complex enough to get the job done. So you can't just say, all right, here's my encryption, and then have a key that's going to be easily compromised or not protected or not available as necessary. Ensuring that this piece is considered as well. With any database level option, of course, you're going to have to consider what happens with your sorting and searching. I mentioned that briefly, really because now that data is stored in an encrypted state, the readable data is not going to be readily sorted on. So when you're doing a sort, when the data is encrypted in that field, you may have to use an SQL statement with an order by instead of allowing that sort to happen as it would before. So you want to definitely use caution with the number of records that you run that over, however, so that you're not trying to do a select all. Of course, you would have to question why, in this case, why someone would be searching or sorting on a field that has sensitive data. It is highly unlikely, but it may be appropriate for certain use cases. We do hear a lot about row column access control. It was added at v7r2 as a way for controlling and protecting sensitive data. What you need to keep in mind is that it secures the data by hiding it from a user, the existence of it from a user that's not authorized, but it doesn't actually encrypt it. And while there's many ways to secure data, when encryption is required, this does not actually meet that mandate. This is not securing data at rest, or it's not encrypting data at rest. It is merely hiding the existence of it, which is security by obscurity. And if that encryption is the requirement, this is definitely not going to meet that. And as with any security measure that we talk about at Fortra and Powertech, and there is no one security tool that can replace poor security practices. So we do see time and time again that organizations rely on one aspect of security for their total security solution. So encrypting data is not getting you off the hook for your poor security practices. You do need to implement additional controls, ensuring that authorized users' access to data should be monitored and controlled on how they get to the data and what they're doing with that. Someone who has the ability to get to the database or the application should not be able to use one of the back doors to the system, such as ODBC, to pull that same database into an Excel spreadsheet and walk away from it. So you have to have other good security practices in place in addition to this specifically. All right, let's do a quick poll. I'm going to launch that for you guys. And I'm actually curious if you've actually ever categorized your data. So, we're talking about sensitive data on a server. I'm curious if any of you have actually gone through and identified whether you're fully aware of all of the sensitive data on your system. If you know generally, but you might need some help identifying it. If you have not actually done so yet, but you need to, or for a fact that you don't have any sensitive data on your system. That one's actually pretty unusual. I don't find that happening very often, but there are some cases for that. If you think about sensitive data, even if it's your customer or if you're a transportation company, it could be driver names. So data that's important to your organization that, if exposed, could easily compromise the business. That's really what that sensitive data and categorizing it is about, ensuring you know where it is and could this be a problem if exposed. All right, I'm going to go ahead and close this poll here in just a second. Most of you guys have actually responded. So 5, 4, 3, 2, 1. I know that was really fast. So I'm going to go ahead and do that. So it looks like most of you have actually done so. I'm going to go ahead and share this out just for fun. So 63% of you say that you are fully aware of the categorized data on your system. Some of you said that you could use some help. Others recognize that, in fact, you need to do it but haven't started yet. And of course, there's always the rebel in the group that says they don't have any sensitive data on their system. So kudos, your job is easier than the rest of us. All right, let's carry on. Thank you for participating there. It's one of those where sometimes you don't think about what would be sensitive and what is not. So let's talk about what you can do for that sensitive data. For those of you who do think maybe you have some important sensitive information on your system that not everybody needs to be able to see. So introduce to you our Powertech Encryption for IBM. Powertech Encryption for IBM allows you to do multiple facets of encryption on the system. So whether you're doing native encryption of your DB2 data at rest, or you want to encrypt IFS stream files, or encrypt to backup media. So with the native encryption for DB2, using those field procedures, you've got that automatic encoding and decoding of data. So when new data gets inserted or updated, that process is triggered automatically and it's stored as soon as it's saved to the database in that encrypted state. When a user goes to read it, it's automatically decoded and the user will be able to see the authorized version for their profile, whether it's fully unmasked, partially masked, or fully masked if they're not authorized at all. So really ensuring that the right people see the right version of the data, regardless of how they access it. So if they have access to a command line and they can do DFU, SQL, try to get any workaround, it doesn't matter. That that masking is gonna be honored regardless of how the user requests it. So that's the benefit of using that field level encryption using the field procedures. We also provide IFS encryption. So what we often forget is that sensitive data from databases is often taken out of those databases, created into additional files that are stored in the IFS. So the data is still sensitive, it's just stored in a different format in the integrated file system. So IFS encryption, you're able to encrypt anything stored in a specific IFS directory. Using our programs, which are tied to IBM's scan exit programs, we're able to automatically encrypt the documents when they're added to the directories, and then when authorized users attempt to open a file, will automatically decrypt for those authorized users. So making that determination, regardless of the object level authorities, will refer to the encryption authority to determine whether or not the user is able to, in fact, open it. You can also encrypt basically anything that's stored in those IFS directories, including PDF documents stored from document management solutions such as Fortress Web Docs. So the ability to ensure that these documents are not compromised and that only authorized users are going to be able to access them. Backup encryption allows you to encrypt and save any IBM libraries, objects, and files in order to protect it on that save media. So whether you're targeting to disk, tape, or any other supported media device, it's going to allow you to apply key-based or password-based protection. Example of that, I had someone who had to send their database to a vendor. They did not want to send it on a tape via one of the big delivery services without it being protected. So they actually used that encrypted save live command and ensured that if somebody were to get a hold of that tape, that it would not be usable. Essentially, native IBMI commands allow you to replace your saved commands with the encrypted save commands, as well as instead of the restore commands, you're going to be able to do the decrypt restore command. So essentially allowing you to encrypt as you save it and decrypt as it's restored in order to protect it. With Powertech Encryption, we also have integrated key management. So there's no external key manager required, which really simplifies the whole process. So having full control over how the keys are managed on the IBMI within the software. So establishing your overall policies on who can create and utilize the keys, who can manage the keys, really being able to create separation of duty, easy key rotation. There are some regulatory requirements that say keys should be rotated on a regular basis. Organizes those data encryption keys into key stores, which then again are in fact secured and using IBMI object authority, as well as encrypted with a master encryption key. You can randomly generate strong encryption keys, control which users can do that encrypt and decrypt of the data, and then also alerting and audit trail entries when anything's modified within the key manager. So you have full visibility and control of how those keys are in fact handled. Encryption itself is very easy when we're looking at field level encryption, being able to pull up based on a library name and show all of the files within that library, how many fields there are, and if they're already been registered in the encryption registry, and if they're active or not. It makes configuration very easy, be able to list out those fields so that you can quickly identify which fields you've already encrypted within the software and which ones still need to be addressed, and adding it on the fly. So really making that very simple process to add the fields to your encryption and activate it in just a few simple steps. Automatically using the encryption algorithm, AS256 and ECB mode, as well as allowing you to add the masking. So determining who's going to be able to see what version of the data and how much they get to see. Social security number, for example, only showing the last four of a social security number and then masking it with characters for the rest of it, ensuring that users are only going to see as much as they need in order to do their jobs. So the registry itself, very easy to identify if in fact you've done your activation of the fields themselves to ensure that it is in fact protected. Masking it is very simple, and determining how much you're going to show and what you're going to fill in the rest of the characters with is done readily within the application. When a user's reviewing the data through either your application, they're going to get the protected view of the data. So if they're not authorized, the application itself still looks the same, the fields look the same, except for they cannot see the existence of the actual data. They're going to see that masked view of it. Unprotected view, straightforward. So whether or not they're looking at the masked version or if they're fully authorized, they're still going to see the data as intended for that user. Or if they see that partially masked view, they're going to see what you've determined is appropriate. So the first two and the last four, or just the last four of a social, and then the rest of that field is masked as appropriate. I mentioned that it's regardless of how you access the data. So it's application agnostic. So if you're looking at that same application data through Query 400, or you're doing a display physical file member or DFU, doesn't matter. Regardless of how you look at that data, if you're authorized to that mask view, that's all you're going to see. So really, ensuring that the data is protected and that there are no backdoors to be able to work around the protections in place. If you have merely an application masking, if the user is in fact able to use one of those backdoors to the system, they can get around those controls. And so we're really trying to take away those ways of circumventing the protections in place. Using query, being able to get to that data, regardless of how they do it, it's honoring that masking. Now, when we look at Powertech Encryption for IBM, it's nice because you get a free 30-day trial. You can download it, get it installed. It is a very small footprint on the system, and getting it up and running is typically done in about an hour. And then you're able to test it in your own environment, make sure that it works, in fact, with your applications and that it does, in fact, address everything that you're concerned about, making sure that, in fact, it does do exactly what you want. When we're looking at security on the system, we also like to provide our free security scan, which gives you a really nice high-level overview of the current security systems on your settings on your system. So think of this as the 30,000-foot view, things that you don't usually step far back enough to actually see as a problem. So this actually comes with a 1-hour review so that you can understand what we were looking for with the security scan and kind of get some ideas for remediation and mitigation. So it can be helpful when you're starting that security journey in being able to identify the areas of concern and what you need to address first, or if you've already started down that path of your security projects and securing the system and the data on your system, this is a good way to check in to make sure that you haven't missed anything. So we strongly encourage customers to take advantage of that so that you can, in fact, get that benefit of an additional eye on your system and evaluating the security from a neutral perspective. All right, one more quick poll. And actually, this one, I'm curious, I did talk a bit about compliance requirements and whether or not you, in fact, fall under any of those. And, it's something where, a lot of people are like, well, no, we don't. We don't have any compliance mandates. And I strongly encourage companies to have your own compliance mandates. You may not have an external entity telling you what you need to do with your system, but you should have a security policy and you should audit your system settings against your internal security policy. So compliance mandates can come from anywhere. And by doing that, you've actually made the system stronger, made the company stronger by, in fact, putting your own requirements in place so that there are standards that are being met instead of, well, we're not sure, we're just going to wing it. But regulatory, whether or not you have regular audits, if you've got auditors, but they don't really bother you much. I know we've heard that, auditors over the years have, they kind of don't understand IBMI, so they kind of skip it or they give you a free pass. But it varies for sure. So, all right, looks like a good bit of you have in fact responded to the poll. Looks like quite a few of you actually have regular audits, and that's surprising. I actually don't see that often. So I'm guessing because you do have audits, that's why you're here, and you're trying to make sure that in fact you do address this. And so I hope that we've been able to provide some information today that makes it seem a little bit less daunting. Really, deciding which approach you want to take with encryption on the system in order to meet some of those regular audit requirements. If you do have any questions, feel free to shoot them over to me. I know we just have a couple of minutes left here, but I'm happy to answer them. Hopefully, we kind of covered the bases there on some of the myths that you may have also been familiar with, and that in fact we kind of clarified for you a little bit about whether or not those are in fact the case. So appreciate your time. If you do in fact think of any questions after the fact, please feel free to reach out. You can email info@fortra.com if you're interested in accessing the recording. Recording link should be sent to you later today. You will also be able to find that available on the website. So we really appreciate you taking the time today. It is, we're all busy, and we do appreciate the fact that you are willing to spend this time with us. If you're interested in the security scan, you can also reach out or send a question into the chat there, and we'll be happy to reach out and get you the information on that.